Hello! In this video we're going to have a look at how to actually analyze the profiling files that we have generated. In this video I'm going to take some real-life profiling information from a WordPress application, and then we're going to have a look with KCacheGrind whether we can find some issues with it. So here we have our demo WordPress application. I'm running WordPress with PHP's built-in web server. Let's recap how to set up profiling with Xdebug. In Xdebug's ini file, or the standard PHP ini file that you have used to load Xdebug itself, you need to configure its mode. I also like to set a different output directory. And lastly, I would like to have my files to have the URL in it. As well as the time. I'm also creating the profile files directory. But let's see whether I have the profiler configured correctly. I do that by checking the output of Xdebug info. In the top section you can see that I have the profiler enabled. And in the profiler section you can see that Xdebug has actually created a profiling file, but it hasn't taken account our output format. As you can see here, I should have used xdebug.profiler_output_name. As you can see, I simply mistyped this. Unfortunately, PHP doesn't tell you when you use a ini setting that doesn't exist. Now let's check our output again. And now in the profiler, you can see that it also has the time in there. The request URL is of course empty because we run this from the command line. Now we can start WordPress again. If you're using PHP FPM, you need to restart that because you have made PHP ini settings. If you use Apache, then you need to restart Apache as well. In this first attempt, we are just checking the front page. I will reload the front page a few times so that we can see potential differences. Let's see which profile files we have created. And here are the 4. I will now open the last one with KCacheGrind. If you want a tour of KCacheGrind's functionality, please refer to a previous video. The first thing to do is to analyze the full call graph. You can do that by selecting the main function. This graph shows all the function calls as long as they have taken up enough time. Usually the longest tail is where your slowest function is, and in the mini view in the top left here, you can more easily see the thicker lines, meaning the slowest function. Having a closer look at the graph itself, we see a few things. First of all, requiring a file takes up quite a lot of time, so we're going to ignore that. WordPress doesn't seem to be using autoloading, so that is strange. Word of note, I have no idea how WordPress works. But we can still draw some conclusions out of this. So there's a few things in here. It says that including WP settings file takes up 73% of the time. That is quite a lot. So let's see what this does. It says do action takes 25%. It says create initial post is 8%. And then load default text domain takes 27%. Because this is included from the WP settings file, this sounds like something it does every single time, but I'm just assuming that here, right? But let's dive into load default text domain. So what does this do? Well, in order to figure out what it does, we can select source code here. There is one call to the terminate locale, but that takes up very little time, so that is not relevant. The biggest thing is the call to load text domain, which makes sense because that is also the one that shows up here. In fact, that takes 26% of the full request. So let's move down here a little bit. And we end up at mo import from reader. And what does this do? Well, it calls p-pomo reader substring 2%, make entry nearly 6% of the full request, and translation key entry 1%. But mo import from reader itself takes 22%. That almost concludes that this function itself has a lot of logic in there. Let me double click it to dive into this. Let's see what this function does. It seems to do some basic checking first, but that doesn't look overly interesting. There's a few calls here. It calls PHP unpack on some files, which takes a few % of the time. Then there is read a substring that takes quite a lot of time here. There's some calls to get headers, and then here there's 3,774 calls to mo make entry. Which makes sense because if you look here, you can also see how often these functions were called, right? So substring was probably called twice for every import, make entry once, and translation entry key also once. At least that's what I'm inferring from here. And that makes sense because you can see in this line that it calls substring on the position and the length, the original one, 3,777 times, and the same thing in the next line for translation. I happen to remember that MO is some kind of data format. It's trying to read translation files, and it looks like it does this every single time, which is of course, not necessarily a good thing to do. There is, however, another way to come to the conclusion to find out what would be the function to look at first, closest wise. At the start of this, I show the whole graph of main, but if you click on self, you order the functions by how much time was taken up in this function without doing other things. And here immediately you see that mo import from reader, again, is the top one, taking up 30% of the full time while doing its own things. 13% is a significant amount of time. Now, it is possible that WordPress does this not in development mode, but I don't know WordPress, so that might as well be the case. Of course, to actually figure out how the code actually works, we need to use a debugger and not a profiler, but I'll save that for another video. Now we have found our first culprit. It is of course the task of the developer to actually come up with a way to improve this function itself, perhaps by caching what it does. But at least we have used a profiler to figure out a function that potentially can be optimized. I would also always have a look at whether some functions are called very often. And you can do that by selecting the called column in the top left. In this case, PHP explode is called 11,000 times, although it didn't really take up a lot of time. But let's see where it was called from. Because this is an internal function, you can of course not see the source code, but we can find out where it was called from by selecting colors. Interestingly, most of the calls are again done in the MO, the loading of translations, from make entry. And you can see in the call graph that is nearly all of the calls, because it only shows up make entry as a parent here. Alright, let's find out why it is called. And I'll double click on make entry to see that now. And we can switch back to source code. So where does it call PHP explode? It calls explode a few different times. First, to look for context separated by the ASCII character 4. I guess that is an internal specification of these MO files. Just then the same again for parts, separated by the null character, and then again one for translation also by the null character. Perhaps it's possible to cache this as well? I do not know, but I don't think it would be as important to cache because it's probably better to cache the import from reader output itself. Now, what else is interesting here? Well, we can have a look at translate, because if you click on self, translate takes up nearly 5% of the requests. And here you can see that translate actually has multiple parents, because it apparently comes from multiple sources. Now, of course, I'm sure if you look in deeper, we can find many other places where we can find some optimizations, but I hope this gave you a bit of an overview on how to use KCacheGrind to actually dive into the profiling files to find some places in your source code that could do with some optimizations. Right now we only had a look at WordPress's front page. Of course, if you want to find bottlenecks in other bits of the code, then you need to create profiling files for all the other operations that you can do as well. Thank you for watching, and I hope to see you next time. If you like this video, please like and subscribe.